Well, I've slept since the last video, but I knew the next thing I wanted to do was just to demonstrate what I've got so far in the product class, just how to use it before I go on and make some tweaks and introduce new concepts about how classes work in C# in particular. So I just added these text boxes and stuff to just as an example, a demo. One thing you'll notice, just a warning, I don't do any data validation or exception handling or anything, because this is just a demo and I want to concentrate on the core of the code. And keep in mind that, like, from now on you should be putting some code in that checks validates data and stuff, and does exception handling when needed, just to make sure your code doesn't crash. But okay, I think the dogs are done barking. So I was talking about making sure your code doesn't crash, and then I was going to show you the code. So what I did is I overrode toString. So this is a thing. I should probably start over because I don't think I think I showed this with the student, but I can describe it again here, I believe. So I'm going to cut this. You just cut this part. Not cut it, but yeah, cut the whole thing. Yeah, I'll cut the whole thing. It's fine. Okay, so what you'll do is you'll go to your, now this is where we left off, I think, with the code. We had the mutators, the accessors, the constructors, and all that, the private instance variables. And then if you do control dot, nope, not like that. Control dot, I know it's a thing. I know it's, just must have typed the wrong thing. You can generate overrides. So if you generate overrides, just pick, for now, we'll talk about some of these other ones later, but just pick toString and click OK. And it'll, what this means is that you're inheriting from the form class, which in turn inherits from the object class. It's a string. Like, imagine your grandparent, right, has this thing called toString, and he passes it down to you. That's what's going on here. By default, you'll have a toString method, which I think prints out the name of the class or something like that in C#. I can't remember exactly what it does. It's totally important, but I guess it has some uses sometimes if you don't override it. But we're going to change it. So it's like you got this thing passed down from your, say, maybe a ring or something, passed down from your grandparent, and then you like and turn it and melt it. No, you wouldn't want to melt it down probably, but incorporate it in some other piece of jewelry or something. I don't know. You change how it works. So that's what we're going to do with toString. So toString is going to be overridden in such a way that whenever you have the context, unambiguous context of a string being needed, this should be called by default. So for its default, it will do the base. So base is a reference to the thing you're inheriting from. In this case, I'm sorry, I said form. It's not. This is not part of the forms hierarchy. This is just this class, what we created, literally inherits from object directly, as if this were explicitly in here. If you leave it out, that's what it does by default. That, by the way, what I just showed you is the syntax for inheritance in C#, but we'll talk more about that later probably. So you inherit toString, but you want to override how it works. So that's why you have this override keyword. It's saying don't use the base class toString, which in this case is object, but use this, what I put here in between the curly braces instead. And by default, it'll just get you started as a stub with base.toString. It'll call the toString of the parent class. And you can see that if you hover over it. String object toString. Returns string that represents the current object. So we don't want it to have that behavior. What the behavior we want it to have instead is this. And this could be whatever you want. I'm just going to make it print out like a little informational thing that shows the code, the description, and then the price and form of currency. So that's how these things are called placeholders. I think there are probably other names for them though, but these correspond to, say, in Java and C#. I mean, sorry, C++ to like %d, %i. They're similar, very similar to that. But instead, you have curly braces surrounding the arguments that you give to it here. See this comma separated list of things that you want to go into each one of these, starting at 0, 0, 1, then 2. You can change the order of these, by the way. Sometimes you'll want to do that. You'll have something in a certain order and you want to change the order that prints out. So you can refer to these in whatever order. It don't have to be 0, 1, 2 in that order. But 0, 1, and 2 correspond to 0, 1, and 2 here, regardless of what's inside the string. And like I said before, once you create these accessors, you should use them throughout your class and also outside your class as a sort of a principle. You don't have to. There could be good reasons why you don't, but I chose to use them here just as a default behavior from when I'm coding things up. So this should print out the code for the object, for the product, the description, and the price. All right. So, and then what I did is I added these text boxes, and then when you run it, you fill these in and click add product, and it'll add it to this list. The way that works, if you double click on the button, you can see all I did. And I want to point this out. Notice something is a little different from what you've seen before. Oh, I forgot to add this too. At the top, I added a list. So this is a generic list collection built into my form class, my class demo form. Like you saw before, probably a lot of you probably use something like this, very similar in your last lab. So I added that, and this is just going to store whatever products I add. And then I did the thing you also might have used in your lab, where you add the things in this list to this list box, right? Which itself, the items is kind of a list too, so it's a collection. But I'm just adding. Whenever I call list products, it will print out. It will add things to the list box. It'll clear out the list box first, so it kind of resets it, and then it'll list everything. But what I want you to show you here is this list that I'm adding to. I'm adding this product to this product list called products. Notice that there's no variable. So I took a lot of shortcuts here. I want you guys to get more comfortable with this. This is not necessarily the best way to do it, especially because, again, no exception handling for format exception in particular. So that would ideally you would have try catch and all that kind of stuff added to it, or like some data validation to make sure that this is actually a decimal that you're adding. But in any case, I'm just using, I don't have helper variables. For instance, I don't say string code gets text code.text, string description gets text description.text. These are strings, so I just put them into the product directly. But the biggest thing that's kind of weird to you is I don't have product P gets new product. I don't have a variable. You don't have to have a variable. You can have the object, the product object, without having the variable. All you have to do is call a constructor. So what I do is I call a constructor with these arguments from the GUI, the front end, right? The text boxes. I call this product using whatever's in the text boxes, and then I add that product object to my list of products. Because this is a product and this is a list of products, so I just add this object to that list. Now you can get at that product that I added, that product object that I just added to my list of my list of products. I can get at it through the list. I don't need a variable. So this is why I kind of impressed before when we were declaring, like this is declaring a variable of type product, and then on a separate line I would say this variable is getting the address of an object that you create. The important thing that you need to focus on is that what's an object and what's just a variable that holds a reference to an object. Here we don't have a variable that holds the reference to an object directly. We have a list, which is a variable. It's a list, but the references to the objects are in the list. They're the items of the list. So in other words, the objects are here. And you've seen this before because you would add it, like maybe say, well, I'm doing it right here, as a matter of fact. That's a variable that gets a reference to a product object, right? And then adds it to the other list, which is in the list box. Let's just run this so you can see how it works. So I put a product code, and again, I'm not doing data validation, so just about anything I can type in here would probably work. What have I been using before? Let's say red ballpoint pen, something like that, right? And the price would be, I don't know, let's say $1.99. Add product, and it just adds it to this list up here. So this is all it does, and you'd have to change this to other things. let's say maybe the blue one, right, is a different product at the same price otherwise. So that's the kind of thing you do. And by the way, like in a really full-fledged project, you would make sure that like you don't have maybe that every product has a unique code that matches a certain pattern. We talked about this before in earlier videos, so I won't belabor it too much here. But anyway, so and I'm just to show, I can keep clicking add product. So in a real product program, you would have quantities probably instead of listing the same thing multiple times, but whatever. You get the idea of how this works now. I don't have an exit button or anything, so I'm just going to click the X to get out of it. But that's just showing you, again, the main thing we want to get out of this little demo is just like how you would use this class in a very simple way. That's just a list of products, right? Ideally, you would have like maybe a database that you would add these products to or that sort of thing. It can get really complex, but just at the simplest level, this is a structure of a basic class. Again, I want to emphasize using like a more traditional, like if you think about how Java works, a more traditional structure of a class. So you would have the private instance variables, the fields. You have maybe you can have a couple or three or however many different overrides you want for your product. I could have one that just has the code, right? And then later I can add the description in the price to that one with that code. So you could have a single argument constructor as well in here. It depends on the business rules, what's allowed. It's kind of like database management. If you had a database class, right, you do business rules where you set up what it means to have a product, and can you have a product without having all three? Can you have a product with having nothing to start with, and then add those things later maybe? That's all decisions you need to make in your design. But so again, you got fields, you got constructors. Let's fold this up, and then you have mutators and accessors, and then we override toString just to show you what that looks like. So this is kind of a traditional design of a class. In the next video, I'll take this and show you. I think the next video is probably going to be my introduction to properties and how properties are a different kind of like .NET Visual C# thing that sort of makes some of the syntax a little simpler. I don't know how I feel about how needed they are, but it's the way things work in the C# world, so you need to learn about them. So that'll be the next video.